Hello everyone! Magandang araw po sa ating lahat. Welcome to the Division Webinar Series on Science Content, Teaching Strategies in the context of the most essential learning competencies for Grade 6 Science teachers for the fourth quarter.
To start our program, let us join in the singing of the National Anthem to be followed by an invocation prayer for an audio-visual presentation.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang magiging telas ng sinakanan, alam ng puso, sa dibdib mo'y buhay. Lupang hinirang, tuyag ka ng magiting, sa manlulupin, di ka pasisigil, sa dagat tutok sa simoy at sa langit mong pagaw, ay hinatang tulad, awit sa pagkayang minamahal. Ang isang ng matawad mo'y tagumpay na nag-iindig, ang bituin at araw niya kailan pang ay di magtitindig. Luman ang araw ng buwan, ating pagsinta, buhay langit sa piling ko. Aming higaya na pagkay mga amin, at mamatay ng dahil sa'yo.
A prayer for teachers. Giver of all wisdom and greatest of all teachers, look upon our teachers with love. Grant them the resolve to nurture our eager minds and to never give up on us who fall behind. Bless their hearts, for they rejoice when we succeed, and encourage us when we fail. Endow them with gentle patience, for the path of learning is never easy. Kindle a spirit of passion in them. It is the flame that ignites the love of learning in us. Help them see the potential in each student. Their belief in us means much more than the grade we make. Instill in them a commitment to keep on learning. It shows us to not fear new knowledge and experiences. Inspire them to touch the future. They influence how big a dream we dream for ourselves. Bless our teachers who have come before, for their work endures to this day. Let the light of your example shine upon all teachers, to build up with their words, to love with their mind, to share with their heart. Amen.
Once again, good day to all, especially to our facilitators and participants for this webinar. I am Alvin M. Santiago, Teacher 3 of Antonio Giliamas Elementary School, Maribeles District.
And I am Claribel Jom R. Concepcion, Teacher 1 of Morong Elementary School, Morong District. And we are your moderators for today's webinar. And to inspire us and welcome us to today's webinar, let us give our virtual applause to our Education Specialist in Science, Dr. Edwin Bermilio. Hello, sir. Welcome po.
Magandang buhay po sa lahat. Welcome to the last wave and leg of our Division Webinar Series on Science Content and Teaching Strategies in the context of the most essential learning competencies for the fourth quarter. Sabi po ni Henry Ford, coming together is a beginning, keeping together is progress, working together is success. And I believe that this highlights the importance of working together in teams for science department from first to fourth quarter of its activities. With this, I would like to personally take this opportunity to express our sincerest gratitude for the success of all our science webinar series. To our school's division superintendent, Dr. Roland M. Fronda, to our assistant schools division superintendent, Sir William Roderick R. Falurin, Words can neither qualify nor quantify how helpful your guidance and advice has been. We are forever grateful for your support sa Science Department. We continuously learning from your examples because your leadership is not just about titles or positions, it's about one life influencing another. Thank you po, Sir Roland and Sir William. To our Curriculum Implementation Division Chief, Dr. Milagros M. Peñaflor, thank you for your trust and confidence. Your support and guidance have been instrumental in helping us to provide quality science curriculum instruction by enhancing the content knowledge and pedagogical skills of our science teachers, including alternative learning system from grades 3 to 12. To our public school district supervisors, science department heads and coordinators, and our elementary school principal coordinators, our sincerest thanks for selfless support in all our endeavor. Your dedication, compassion, skill, and professionalism will allow us to get through all the activities with flying colors. And we are all indebted to you. We appreciate your sacrifices to be at work. We want you to know that your actions are seen and appreciated. To our team leader and assistant leaders per grade level who had been working countless hours to make sure that everything is okay. Sabi po ni Mother Teresa, God does not command us to do great things. God commands us to do little things with great love. Not all of us can do great things, but we can do small things with great love. Maraming salamat po sa pagmamahal. Amidst the challenges, I am also very grateful to have our intelligent, strong, competent, and brave resource speakers who took the challenge as learning facilitators. Thank you for great performance, dedication, and expertise in delivering quality instruction to the teachers and learners of the SDO Bataan. Of course, special thanks to the members of the program management team in charge for online platform, program design, Google Forms, and our moderators for the hard work and for silently working behind the scene just to make sure that we have tools and resources available. We value all your dedication to keep us up and running. Your efforts are truly appreciated. To our science teachers, we hope that the trainings we have provided will help contribute improve students' learning outcome, develop strategies and approaches, and encourage quality implementation of science curriculum and implementation. From the first until this fourth quarter webinar series, your individual commitment to a group effort is what makes a science department. Maraming salamat po sa lahat. God bless us all.
Thank you, Sir Edwin, for the very encouraging welcome remarks. And now, let us listen to an inspiring message from our Curriculum Implementation Chief. Let us welcome Ma'am Mila Peñaflor. Let's give her a virtual applause.
Today is your last among the 4 webinar series of this kind in science. I am glad that you all were able to make it. Congratulations to everyone, my dear science teachers, department head, principal coordinators, and to Sir Edwin Bermilio for the untiring efforts in bringing a quality science instruction to our young people amidst the challenges. We are now on the 4th quarter. It's like that we are ending the school year, but most of the wrapping up activities will be in this last quarter. The remediation, the catching up activities, plus of course, the readiness of our learners for the year-end assessment. Let us see to it that all competencies reflected in the most essential learning competencies are learned by our students. The provincial government, in line with the development of the Human Index, would like to measure how our schools perform, how our learners fare considering the implementation of the learning continuity plan of our schools. I know that it is really hard to cope up with the many challenges, but I have seen how you did it with so many times with the issues and concerns in science. The challenges lies not only with our learners having the competencies, but how we make them critical and creative thinkers. Today's session hopes to deliver both as our competent speakers dwell on interesting topics, putting premium on the plight of our teachers in teaching the skills, how this could be a ready hand for teaching lifelong learning skills in science. Thank you for everyone's participation in this webinar. Thank you for your resiliency in pushing through up to this last quarter. Thank you for keeping up with your promises para sa bata, para sa bayan. Happy day, happy learning, and God bless us all.
Thank you, Ma'am Mila Peñaflor, for a very inspiring message. And now to give us also a message, let us welcome our Division Superintendent, Dr. Roland M. Fronda. Good day po, sir.
Good day to all the participants in the webinar series on science content and teaching strategies in the context of most essential learning competencies for the fourth quarter for grades 3 to 12 in SDO Bataan. We are nearly 1 month to go before the closing of school year 2021, and we have hurdled, we have surpassed, we are survivors. This event likewise culminates the webinar which the division have initiated from the first quarter up to the last quarter. And I am certain that what we have experienced from the time we started this uncertain and ambiguous journey, it has taught us a lot of lessons how to cope with all these challenges. In our present system and practices in education, particularly in these trying times of uncertainty, many of us would surmise that our education systems are not well aligned with the overall goal of learning. Other goals can detract from, and in some cases, compete with efforts to improve learning outcomes. We could also infer that the elements of an education system are often incompatible or incoherent. For example, our government funding allocation sometimes fail to provide the resources schools need to improve learning, and even the school funding is available. The rules governing its use often leave little flexibility for schools to use it in ways tailored to specific needs of students. What we can do is to become resilient. No, it's resiliency is actually the byword of the pandemic. No, to promote resiliency, no, as science teachers, no, we must consider our strengths and our assets in education communities and systems to support our students in making sense of the adversity they experience. I know that it's not only the students who are experiencing adversity, but also our teachers, our school administrators. We should find the very purpose in education and develop the needed skills and competencies. We need to upskill ourselves as well as teachers. Your collective participation in this kind of academic exercise can propel our mutual support and commitment to learning, because protection and well-being of our students, our staff, and our families that are affected by this great educational challenge is paramount. Well, to put emphasis resilience matters because not only is learning and school success possible in spite of adversity, education can also be the vehicle to overcome the adversity. To Dr. Peñaflor, our CID chief, to Dr. Bermilio, and to all the participants, thank you very much for sharing to us your precious time to actively participate in this kind of activity, this half-day activity. I believe this will end until the Friday of this week. I hope all your sharings of experiences would give us feedback to calibrate and redirect our compass what to prioritize because we value your observation, we value your inputs and recommendation to better improve our service. We want to make sense and find our purpose that in turn will allow us to make meaningful and positive decisions as we mold heroes in Bataan. Magandang araw po sa ating lahat. Pagpalain tayo ng dakilang Diyos at patuloy po kayong mag-ingat.
Thank you, sir. To our Division Superintendent, Dr. Roland M. Pronda. Once again, good day po, sir.
Before we start our discussion with the facilitators, let us first observe some house rules. And these are our webinar house rules. One is no spamming.
And number 2, remember to be polite at all times.
Number 3 is pay attention to the presentation.
And of course, number 4, we have to participate on this webinar.
And the last but not the least, if you need to ask questions, use the menu button to raise your hand so you can be acknowledged.
Yes, and I guess we are all set. Let us all get started. At this point, our dear co-teachers, we are pleased to introduce to you our first facilitator, graduate of Bachelor of Arts in Psychology at the Philippine Normal University. She is also a Master of Arts in Education Management graduate at Tomas del Rosario College at Balanga City. And being in the service for 15 years, and she is also a special science teacher for 10 years. Master Teacher 3 of Capcaben Elementary School. Walang iba kundi si Ma'am Rosalyn B. Angeles to discuss content changes in Earth's surface.
Good day, everyone. I am Rosaline B. Angeles, Master Teacher 2 of Capcaben Elementary School, Mariveles District, and I will be one of your facilitators today. Our session aims to identify what is an earthquake and a volcanic eruption, its types and characteristics, and to enumerate ways on what to do before, during, and after an earthquake and volcanic eruption.
Hi, I am Teacher Sasa, and welcome to our science class. Today, we are going to talk about two of the most common natural disasters here in the Philippines. Do you know what it is? By simply looking at our clips, can you guess our topic for today? Correct! Our topic for today is about earthquakes and volcanic eruptions. Have you experienced an earthquake? How about a volcanic eruption? Can you share to the class what you felt? What did you do? Tell us your experience about it.
Despite our tendency to consider Earth as static, it is actually a dynamic and ever-changing planet. Wind, water, and ice erode and shape the land. Volcanic activity and earthquakes alter the landscape in a dramatic and often violent manner. And on a much longer timescale, the movement of Earth's plates slowly configures oceans and continents. Each one of these processes play an important role in the change of the Earth's surface. An earthquake is a sudden movement or vibrations of the crust, the Earth's rocky outer layer. It is caused when rock masses suddenly shift in position. As the rock masses shift into new positions, the energy stored in the rock masses is transmitted onto the surface in the form of seismic earthquake waves. Violent earthquakes are triggered when two plates slide past each other along faults. Within a fault, the weakest part where the slippage of rocks occur is called the focus of origin. The area above the focus is called the epicenter. Strong shaking of the ground is felt at the epicenter. As the rock masses slide and slip against each other, the stored energy is released and moves outward in all directions as seismic waves. There are two types of earthquakes: the volcanic earthquakes and tectonic earthquakes. What is a volcanic earthquake? A volcanic earthquake is the shaking of the ground that happens when there is a strong volcanic eruption. It occurs in areas that are associated with volcanic activities, such as Mount Mayon in Albay, Mount Taal in Batangas, and Mount Pinatubo in Zambales. On the other hand, tectonic earthquake is caused by the movement of the Earth's crust or crustal plates. A tectonic earthquake may occur above the ground or beneath the ocean. The strength of an earthquake can be described in terms of magnitude and intensity. Magnitude refers to the amount of energy released by an earthquake from its focus, while intensity refers to the effect of an earthquake, especially the damages. The Richter magnitude scale is used to describe the strength of an earthquake that is based on the height of the wave measured in the seismograph. The Richter scale of magnitude was created in 1935 by the American seismologist Charles F. Richter. The destruction caused by an earthquake depends on its magnitude and extent of shaking. High magnitude and long ground shaking during an earthquake can cause tremendous effects such as destruction of property and loss of lives, landslide and avalanche, fire, and tsunami.
Preparedness for natural calamities such as earthquakes include knowing what to do before, during, and after it. The individual person, the community, as well as the government must work together for the safety of the people to minimize casualties. At this time, let us listen to Matea Wong as she gives us information and tips on what to do before, during, and after an earthquake.
Prepare an escape plan. This includes knowing beforehand where to seek cover, all the exits, and meeting places. Prepare a survival kit, which may include a mask, flashlight, whistle, things we need for first aid, water, and non-perishable food. Remember to put the survival kit in an accessible place. And make sure your cell phones are always charged and all emergency numbers saved on your phone book. During an earthquake, remember to duck, cover, and hold. Duck. We drop down to the floor with your arms protecting your head and neck. Cover. Take cover under a sturdy desk or seek cover against the wall away from glass windows. Hold. If you take cover under a sturdy furniture, hold on to it and be prepared to move with it. Hold the position until the shaking stops or it is safe to move. When you're eating in the dining room, secure all breakables before taking cover. Or seek alternative covers away from falling plates. When you're using the laptop, bring it to the ground to avoid it falling on your head. When you're sleeping, stay calm, cover your head with your pillow, or take cover under the bed. When cooking in the kitchen, be sure to turn off the stove and the gas before seeking cover. When you're outside, stay outside. Stay away from utility poles and outside walls of buildings. Also, stay away from crowds to avoid stampede. After an earthquake, check yourself and others for injuries. Be careful of broken glass and debris. And also expect and prepare for aftershocks. And always remember, before, during, and after an earthquake, to seek God. Because we know that our God is an all-knowing, all-present, and all-powerful God.
Wow! That was great! Good job, Matea! Another common natural disaster, especially here in the Philippines, is the volcanic eruption. The very recent volcanic eruption happened just last year when Mount Taal in Batangas exploded and where many livelihood, infrastructure, and properties were greatly affected.
This is a volcano. A volcano is an opening in the Earth's crust where lava, molten rocks, gaseous materials are forced out through its opening. In the Philippines, we have about 100 volcanoes, and 23 of which are active ones. Here are some of the volcanoes in the Philippines. This is Mount Bulusan in Sorsogon. This one is Mount Pinatubo in Zambales. Mount Canlaon, which is located in Negros Oriental. And this is Hibok-Hibok in Camiguin. Actually, if you can observe, volcanoes differ in sizes. Some are low-lying and small like Taal Volcano in Batangas, and some are tall, like Mount Mayon in Albay. Well, do you know how a volcanic eruption occurs? A volcanic eruption begins when tectonic plates collide. Massive rocks underground deform and trigger a build-up of temperature and pressure. This high temperature and pressure results in the melting of rocks and become magma. When pressure builds up, magma rises in the surface, and volcanoes erupt to release the pressure with lava and other gaseous materials. What are the parts of a volcano? This is the crater, the opening of a volcano. And deeply under it is the magma chamber. Molten rocks inside this chamber is forcefully driven out by intense heat and pressure. When magma is released from the crater, it is called volcanic eruption. The magma that flows out of the surface is called lava. This is the volcanic vent, which connects the magma chamber and the crater. Other volcanoes have secondary vents or side vents, which is also a way out for the magma. When volcanoes erupt, it throws out lava, together with gases, rocks, and ashes. A volcanic eruption may be explosive or non-explosive. An eruption is explosive when a large number or amount of pyroclastic materials are ejected by the volcano into the air. But what is a pyroclastic material? A pyroclastic material consists of lava, volcanic ashes, and rocks. Do you know that an explosive eruption could last for several hours or even days? In a non-explosive eruption, lava just flows out of the crater and gaps off the volcano. This kind of eruption happens when there is less pressure in the magma chamber. There are different kinds or stages of a volcano. These are active volcano, dormant volcano, and extinct volcano. A volcano is considered active when it is currently erupting or showing regular signs of activity like earthquakes and significant gas emission. An active volcano has a recorded eruption within 50 years. In the Philippines, we have about 23 active volcanoes. Some of these are Mount Mayon in Albay, Mount Taal in Batangas, and Mount Pinatubo in Zambales. On the other hand, volcanoes that erupted and then have entered a long period of inactivity is called a dormant volcano, or it is also known as a sleeping volcano. According to seismologists, the longer the period of dormancy or inactivity, the greater the chance of having a very explosive eruption that is in the future. For example, Mount Pinatubo erupted explosively in June 1991 after being dormant for about 600 years. Extinct volcanoes are volcanoes that have not shown signs of activity for a long period of time and has no records of volcanic eruptions in the past thousands of years. Actually, whether the volcano is truly extinct is often difficult to determine.
volcanoes can be beneficial to humans living on or near them. They produce fertile soil, provide valuable minerals, water reservoir, geothermal resources, and scenic beauty. But like any other natural disaster, a volcanic eruption can cause hazard not just to humans but also to the environment.
During a volcanic eruption, a very hot lava flow can burn anything in its path. The mud flow or lahar can cause landslide flooding and immense damage to buildings and farms. Volcanic ash and dust released in the air can irritate the lungs and can cause health problems. Very strong eruption can also trigger earthquakes and cause damage in buildings and other properties. Volcanic activities play a very important role in reducing global temperature and thereby reducing the overall warming trend. Volcanic eruptions can inject clouds of dust and gas in the stratosphere and block the incoming sunlight, reducing the heat energy input to our planet. Major volcanic eruptions such as Mount Pinatubo in 1991 reduced the world climate for a year or two. It was documented that the eruption of Mount Pinatubo alone in 1991 that blasted huge dust particles into the stratosphere had lowered the global temperature to about 0.5 to 1 degree Celsius for 1 year after its eruption.
Volcanic eruption may happen anytime. For example, after 42 years, last year's Taal volcano eruption has affected thousands of families and caused millions worth of damage, just days the initial eruption on June 12. That is why it is important to know what to do and how to react when it happens. To help everyone stay safe, here is a guide on what to do before, during, and after a volcanic eruption.
Be aware of any unusual volcanic activity, especially if you are living near a volcano. Listen to the radio or people of authority for safety instructions. Prepare emergency supplies like flashlights, candles, matches, and first aid kits. Stock some food and water. Evacuate if necessary. It is not safe to stay at home and wait for the start of an eruption. Prepare masks for the nose and mouth. They are to be used in case of an ashfall or volcanic smog. If caught indoors, close all windows, doors, and other openings. Remain indoors. Cover your nose with a mask or damp cloth when volcanic ash or dust is present in the air. Keep your food and water covered. Stay away from low places. Rocks, lava, and mud flows are likely to flow towards low-lying areas. Stay in the evacuation center. Avoid going back to your house while the volcano is erupting. After the eruption, do not go back home right away. Wait for further instructions on when it is safe to return home. Avoid crossing a bridge when lahar flows under it. Remove ash from your roofs. Ashfall can cause your roofs to collapse. Check if your drinking water is clear and if the electrical wirings at home are intact and safe. If you have respiratory ailments, stay indoors. That is, to avoid inhaling dust and ash. Follow local health officials. Seek advice if it is safe to go outside.
Above all, let us not forget that our best weapon in times of disasters like earthquakes and volcanic eruptions or a global pandemic is our strong faith in God. Thank you for listening. I hope that you have learned a lot from our lesson today. Join me again next time in our science class. Stay safe. Bye.
Those were very fruitful ideas from our first content speaker, and we had gained significant knowledge and skills. Thank you, Ma'am Rosaline from Mariveles District. And now let us proceed to our second facilitator. He is a teacher 3 from St. Francis Elementary School, Limay District, also grade 6 science teacher for 6 years. And today he will be showcasing the strategies relevant to the content previously shared with us. Let us all welcome Sir Derwin C. Perez. Take it away, sir.
Good day, teachers! Welcome to the Division Webinar Series on Science Content and Teaching Strategies in the context of the most essential learning competencies for Quarter 4. I am Jerwin C. Perez, Teacher 3 from St. Francis Elementary School, Limay District.
As we all know, teaching under the new normal situation is very challenging. That's why, for this session, we will be talking about simulation as a strategy in teaching science subject which students and teachers can use even if they're at the comfort of their homes. What is simulation? Simulation refers to the imitation of real-world activities and processes in a safe environment. It aims to provide an experience as close to the real thing as possible. However, a simulated activity has the advantage of allowing learners to reset the scenario and try alternative strategies and approaches. It also motivates students by keeping them actively engaged in the learning process through requiring that problem-solving and decision-making skills be used to make the simulation run. And as the simulation runs, it is modeling a dynamic system in which the learner is involved. Why are simulations useful in teaching? Here are some reasons why science teachers should use simulations. Number 1. Simulations allow for more laboratory experiences. With virtual simulations, students get to visualize and interact with concepts outside the realm of a traditional laboratory. Some simulations offer a full laboratory experience, thus allowing students to participate in laboratories that are typically reserved for teacher demonstrations. Number 2. Simulations make it easy for every student to participate. Simulations let each student practice and interact with scientific skills and concepts. This allows for multiple and varied data sets to be collected, analyzed, and shared in a collaborative group. When each student is fully engaged in the learning process, they can share their experiences and discuss the results with more confidence. Number 3. Simulations are interactive so students retain what they've learned. Using simulations in teaching science can enhance students' skill development as well as their conceptual knowledge of science. Students practice real skills by manipulating variables. Thus, meaningful learning and the retention of knowledge will be achieved, all within a safe environment. Number 4. Simulations can provide immediate feedback. Raw data, successful completion notifications, failed attempts, or even culminating reports are possible with simulations, thus allowing students to correct misconceptions and teachers to intervene in the midst of the learning process. Number 5. Simulations are safe and cost-effective. Teachers can assist individual students instead of having to continually monitor adherence to laboratory procedures and safety. Supplementing traditional laboratories with simulations provides each student with a hands-on experience and reduces the amount spent on expensive laboratory instruments and supplies while increasing their laboratory experiences. And now, let us watch a demonstration teaching using simulation as a strategy. Good morning, children! Hello there! I am Teacher Jeff, your science teacher. How are you today? Are you ready to learn exciting lesson in science? Are you ready to explore, discover, and learn new science concepts? Well then, Bring out your pen and paper as I take you to the amazing world of science. Come on! For today, we will learn about the volcanoes and how it may change on Earth's surface, right here in our Science 6 class. Our competency is describe the changes on the Earth's surface as a result of earthquakes and volcanic eruptions. Our code is S6ES-4A-1. And at the end of this lesson, you are expected to number 1, define what volcanic eruption is. Number 2, describe how a volcanic eruption occurs. And number 3, discuss the effects of volcanic eruption resulting to changes on the Earth's surface. In our previous lesson, you have learned about earthquake and how it affects the Earth's surface. And as a review, let us play a game called Fact or Bluff. If the statement about earthquake is true, say fact. But if it's false, say bluff. Are you ready? Let's begin. First statement. Earthquakes can cause changes on the land features of Earth and on the bodies of water. Is it a fact or a bluff? The correct answer is fact. Number 2. Earthquake damages depend on some factors like distance from the origin of earthquake, intensity, and the type of ground on which structure stand. Is it a fact or a bluff? The correct answer is fact. Number 3. Earthquakes can cause destruction of structures and agricultural products. Is it a fact or a bluff? The correct answer is fact. Number 4. Earthquakes can cause changes on the land features like cracks on the ground, formation of mountains, hills, and craters. Is it a fact or a bluff? The correct answer is fact. Number 5. Earthquakes can cause landslides, fires, tsunami, and volcanic eruption. Is it a fact or a bluff? The correct answer is fact. Now, how many of you got 5 correct answers? Very good. That's great. Are you familiar with this landform? Maybe some of you are not. But if you live in the town of Mariveles, I am sure that you know the name of this landmass. Yes, this is Mount Mariveles. It is a dormant volcano and the highest point in the province of Bataan. Did you know when was the last eruption of this volcano occurred? It happened about 2050 before the Common Era. Now you know. In this lesson, you will know more about volcano and volcanic eruption. Come on, let's explore. A volcano is an opening in the Earth's crust where lava, pyroclasts and gases are given off during volcanic eruption. It is a landform through which magma reaches the surface of the Earth. In the Philippines, there are many volcanoes because we lie in the area called Pacific Ring of Fire. It is a region in the Pacific where many volcanic eruptions and earthquake occurs. Some of the well-known volcanoes in the Philippines are Mount Bulusan in Sorsogon, Mount Pinatubo in Zambales, Mount Canlaon in Negros Oriental, and Mount Hibok-Hibok in Camiguin. Volcanoes may vary in size and shape. Some volcanoes have a narrow base and steep sides like Mount Babuyan in Babuyan Island. These volcanoes are called cinder cone volcanoes. Volcanoes may have a wide base and gentle slopes like Mauna Loa in Hawaii. These volcanoes are also known as shield volcanoes. Sometimes they are also towering cone-shaped mountains like Mount Mayon in Albay. These volcanoes are called composite or stratovolcanoes. The one which was formed by the mountainous accumulation of volcanic materials is called the cone. The crater of the volcano is a steep wall depression at the top of it. It is the opening of the volcano where the lava comes out during eruption. The one that connects crater to the magma chamber is called the vent. Some volcanoes may have secondary vent. Magma chamber is where the magma given off by a volcano comes from. Volcanoes are formed when magma from within the Earth's upper mantle finds its way to the exterior of the Earth. It erupts to produce lava flows and ash deposits. Over time, a volcano will get bigger and bigger as it continues to erupt. And now, for you to know more about volcanic eruption, let us perform this activity. For our experiment, we will need the following: baking soda, vinegar, dishwashing liquid, red food coloring, a small bottle like soft drink or water bottle, clay, goggles, face mask, and apron or laboratory gown. For our procedure, first, wear protective gear before you start the activity. Make sure that you do this activity with an adult supervision. Second, cover the bottle with clay. Shape it like a cone or a mountain. Leave the opening of the bottle open. Third, put about 4 tablespoons of baking soda into the bottle and add several drops of dishwashing liquid and food coloring. Number 4, Add 50 milliliters of vinegar into the bottle. And then, observe what happens. And now, after the experiment, let us answer the following questions. Number 1. What have you observed after you pour the vinegar into the crater of your volcano? Yes, you're right. The bubbles produced by pouring the vinegar into the mixture burst out of the volcano. Number 2 question. What might have caused the vinegar and the baking soda to burst out of the volcano when they were mixed? Alright, very good. It burst out because of too much pressure it created inside our volcano. Now, what can you conclude from our experiment? From this experiment, we can conclude that volcanic eruption happens if the molten rock inside its chamber is forcefully driven out by intense heat and pressure. But did you know that volcanoes can be classified according to the record of eruption? Yes, it is. An active volcano erupts continually or periodically. An inactive volcano can be dormant or extinct. Dormant volcano is one that has already erupted sometime but is now inactive. It is also known as sleeping volcano. Extinct volcano is one which has not erupted or are not expected to erupt in the future. Volcanoes are exciting. Eruptions demonstrate the power of nature to shape the land in a dramatic way. They can create beautiful displays like erupting lava and even lightning. However, do not be fooled, they are a dangerous force. Volcanic eruptions are not always alike. Volcanoes may erupt quietly or violently depending on the amount of pressure which forces the lava out of the crater. Volcanic eruptions can have a devastating effect on people and the environment. However, unlike earthquakes, volcanoes can also have a positive impact on an area. And these positive impacts can help to explain why people choose to live near volcanoes. And here are the beneficial and harmful effects of volcanic eruption. Here are the good and beneficial effects of volcanoes and volcanic eruption. Number 1. Steam that comes out through holes called fumaroles produces geothermal energy to generate electricity. Number 2. Lava and volcanic ash make the soil around the volcanoes fertile and rich with minerals. Number 3. Volcanoes transport materials from deep inside the earth and are added to the surface, building a landform. Number 4. Volcanoes are sources of useful gases like sulfur dioxide, ammonia, methane, and helium. Number 5. Rocks are used to build roads. Pumice is used in grinding and polishing surfaces. Volcanoes send out useful gases like nitrogen, hydrogen, and carbon dioxide. They are needed by plants to manufacture food. Volcanoes add beauty to the landscape and attract tourists and other visitors. Volcanic eruptions also enable scientists to learn more about the interior of the Earth. Now, here are the harmful or bad effects of volcanic eruption. Number 1. Hot materials expelled can kill people and animals. Number 2. Lahar destroys houses, buildings, bridges, and the entire landscape. Number 3. Volcanoes also expel poisonous gases. Number 4. Changes on the surface may accumulate into piles that may destroy waterways and block trouble routes. Number 5. Ashes and gases sent out can block out enough sunlight, causing the temperature to decrease. This change in temperature can disrupt the climates all over the world. Number 6. Volcanic eruptions cause earthquakes as well. And lastly, number 7, volcanoes release gases that can cause skin allergies or asthma. In this lesson, we have learned that volcanic eruption can cause so many changes, both good and bad. It affects not just people and their property. Plants and animals are also affected. Even the land may be changed by volcanic activities. For me to know if you have prior idea about our today's topic, let's answer the following questions by choosing the letter of the correct answer. Congratulations, learners! You all did great today. Did you enjoy our science adventure? That's awesome! This is really a fantastic journey with you kids. And I am so excited to join with you again next time for another video lesson episode as we explore better science subject. Once again, I am Teacher Jet. Goodbye!
Wow! Those very comprehensive topic po, Sir Jerwin, from our second speaker. And once again, thank you, Sir Jerwin from Limay District.
And now let us proceed to our third facilitator. She will be discussing the content, the solar system, a science teacher at the Bataan National High School in Bataan District. Walang iba kundi si Ma'am Sarah Jane A. Timbang.
Welcome to the Vision webinar series on science content and teaching strategies in the context of most essential learning competencies for grade 6 science teachers. My name is Ma'am Sarah Jane A. Timbang, Teacher 1 of Luwakan National High School. Good day, teachers, and welcome to another episode of Learning. Our lesson for today is about the solar system. I'm sure you are all knowledgeable about this topic, but let us review facts to be more ready and equipped. Our target for today is to compare the planets of the solar system and construct a model of the solar system showing the relative sizes of the planets and the relative distances from the Sun. Before we proceed to our discussion, let us have this warm-up activity. Are you ready? The title of this activity is Come on and Guess Me. Here are the mechanics. Pictures will be presented. It can be 2 or more pictures. First, you need to name each picture. And then, try to connect the words or how it sounded like. After that, you can guess the word. For example, the color red and a cross. I will give you 5 seconds to answer. Your answer? Okay, red cross. Are you ready? Here's the next picture. The first picture and the second picture. You have 5 seconds to answer. Go! What is your answer? Correct. Planet. Here's another. The past tense of sit and turn. 5 seconds to answer. Go! Your answer? Correct. Saturn. The first picture is a short term for elementary. And then a lot of men. Can you guess? Good job! It's elements. This one's a compass and different positions. What do you think is the word? Very good. Composition. These ones are last for our warm-up activity. The first picture is solar, the second is siblings as in sis, and a stem. Solar, sis, and stem. What do you think is the word? The answers comes in 2 words. The answer? That's right, solar system. I'm sure you are all warmed up. So now, let's begin with watching the short video clip about the solar system. What is solar system? It is a gravitationally bound system of the sun and the objects that orbit it, either directly or indirectly. The largest are the 8 planets, dwarf planets, and small solar system bodies. It was formed 4.6 billion years ago. Some scientists say it started with a blast known as the Big Bang Theory. Solar system is located in the Orion Arm, 26,000 light-years from the center of the Milky Way galaxy. As we all know, solar system is only a part of the Milky Way galaxy, a portion of the vast universe. Before, philosophers believed that Earth was the center of the solar system, as they call it geocentrism. But apparent shift in the position of a star created by Earth's motion around the Sun, providing the first direct experimental proof of heliocentrism. That's why now they believe that the Sun is the center of the solar system. The principal component of the solar system is the Sun. Sun is believed and proved to be the center of the solar system. It is the solar system star and belongs to the group of yellow dwarf. Sun is the most massive component, which comprises of 99.86% of all the mass in the solar system. Its mass is 333,060 times the Earth. Its surface temperature ranges from 5,500 degrees Celsius and its internal temperature is 15 million degrees Celsius. Its energy output is called as the electromagnetic radiation. Its sunlight takes 8 minutes before it reaches the Earth. Before we proceed to learning about planets, let us first discuss this. Astronomy and planetary scientists. What are these two? Astronomy is the study of everything in the universe beyond Earth's atmosphere. That includes objects we can see with our naked eyes, like the sun, the moon, the planets, and the stars. It also includes objects we can only see with telescopes or other instruments like faraway galaxies and tiny particles. While planetary scientist is someone who studies solar systems and also anything found in a solar system. Example, planets, moons, asteroids, meteorites, comets, dust. Planetary scientists are generally hybrid experts in astronomy, geology, chemistry, physics, and/or biology. Let us proceed with discussing the inner planets or the terrestrial planets. To begin with, let us start with Mercury. Mercury is named after the messenger for their gods. It is the closest planet to the Sun with a distance of 57,909,227 kilometers or 0.4 AU. AU here means astronomical unit. In the International System of Units, it is the unit of length. Mercury is the smallest planet in the solar system. Its surface temperature ranges from -173 degree to 427 degrees Celsius. The surface of Mercury, which faces the Sun, sees temperatures of up to 427 degrees Celsius, while on the other side, this can be low as -173 degrees Celsius. This is due to having no atmosphere to help regulate the temperature. Mercury has no natural satellites, and its element composition is iron. Our weight on Mercury would be 38% of our body weight on Earth. A solar day on the surface of Mercury lasts 176 Earth days, and a year on Mercury takes only 88 Earth days. Let us proceed with Venus. It is named after the Roman goddess of love and beauty. Its distance from the Sun is 107.51 million kilometers, or 0.7 AU from the Sun. It is close in size to Earth with 0.815 Earth mass. A day on Venus is longer than a year. It takes Venus to rotate once on its axis than to complete one orbit of the Sun. That's 243 Earth days to rotate once, the longest rotation of any planet in the solar system, and only 224.7 Earth days to complete one orbit of the Sun. Venus spins clockwise on its axis, and it is the second brightest natural object in the night sky after the Moon. It is the hottest planet, with surface temperatures over 400 degrees Celsius, and most likely due to the amount of greenhouse gases in the atmosphere. Next is Earth. The Earth is not named after a god because according to the science of the time when planets were being named, the Earth was not a planet at all. Its distance from the Sun is 151.7 million kilometers, or 1 AU. The name Earth is derived from both English and German words Eor and Eartha and Erde respectively, which mean ground. Earth is the largest and densest of the planets, the only one known to have current geological activity like volcanic eruptions and earthquake. And it is the only place where life is known to exist. It has one natural satellite, and that is the Moon. It is composed mostly of iron, oxygen, silicon, magnesium, sulfur, nickel, calcium, and aluminum, with the remaining 1.2 consisting of trace amounts of other elements. Name an element and you could find it on Earth. Next is the fourth planet, Mars. Mars was named by the ancient Romans for their god of war because its reddish color was reminiscent of blood. It is often called as the red planet. Its signature color comes from the large amount of iron oxide or rust. Its distance from the Sun is 249.49 million kilometers or 1.5 AU. It can get pretty cold on Mars since it's further away from the Sun. It is the second smallest planet in the solar system after Mercury. It has an atmosphere of mostly carbon dioxide. A day on Mars is 24 hours and 37 minutes, and it has 687 Earth days. Mars has two tiny natural satellites or moons, and their names are Deimos and Phobos. Mars is made up primarily of silicon, oxygen, iron, and magnesium, and probably has the consistency of soft rocky base. Humans have not yet been to Mars, just like on movies, but scientists have sent a spacecraft there to help them research this fascinating planet. The first spacecraft to land on Mars were the Viking landers in 1976. Let's take a break with planets. We have here asteroid belt. It is a minor planet of the inner solar system. Asteroids smaller than 1 meter are usually called as meteoroids and micrometeoroids. and the larger ones are called as planetoids. The asteroid belt occupies the orbit between Mars and Jupiter, between 2.3 and 3.3 astronomical units from the Sun. Asteroids are composed mainly of refractory rocky and metallic minerals with some ice. Next to discuss are the outer planets or the giant planets. They are sometimes called as Jovian planets. Collectively, make up 99% of the mass known to orbit the Sun. Jupiter and Saturn together are more than 400 times the mass of Earth. They are called the gas giants. Uranus and Neptune are less massive and have their own category as ice giants. The first outer planet is the Jupiter. Jupiter is the solar system's biggest planet. It was named for the king of the Roman gods. Its distance from the Sun is 755.47 million kilometers and or 5.2 astronomical unit. The mass of Jupiter is 318 times as massive as the Earth. It has 79 known satellites or moons. The four largest, the first one is the Ganymede. It is the largest satellite in the solar system. Callisto, Io, and Europa. Although Jupiter is big, it is the fastest spinning planet in the solar system. It makes up 10 hours to complete a full rotation on its axis. It is composed largely of hydrogen and helium. Uranus and Jupiter have ring systems of their own. Jupiter's were the third set to be discovered due to the fact that they are particularly faint. Let us have the second gas giant, the Saturn. Saturn is named for the Roman god of agriculture and wealth, who was also the father of Jupiter. Its distance from the Sun is 1.4875 billion kilometers or 9.5 astronomical unit. It is distinguished by its extensive ring system, and it is also the second largest in the solar system. Did you know how many rings does Saturn have? From what we might be able to see, there are 3 rings. But with powerful telescopes, you can make out 8. And with spacecraft, the total rises above 30 up to thousands. Saturn has more moons than any other planet. 20 new moons were discovered in 2019, bringing the total to 82. Saturn is also the flattest planet in the solar system. Also, it turns on its axis once every 10 hours and 34 minutes, giving it the second shortest day of any of the solar system's planets. It is made mostly of hydrogen and helium. First of the ice giants is Uranus. It is named after an ancient Greek god of the sky who was also the father of Saturn. Its distance from the Sun is 2.9544 billion kilometers and or 19.2 astronomical unit. It is 4 times larger than Earth. Uranus takes about 17 hours to rotate once. We call that as a Uranian day, and about 84 Earth years to complete an orbit of the Sun. It has 27 known satellites or moon, and the largest ones being Titania, Oberon, Umbriel, Ariel, and Miranda. Uranus is the lightest of the outer planets. It is made of water, methane, and ammonia fluids above a small rocky center. Last is Neptune. It is named after the Roman god of the sea. The distance from the Sun is 4.4755 billion kilometers and or 30.1 astronomical unit. A year on Neptune lasts 165 Earth years. It has 14 known satellites. The largest, Triton, is geologically active with geysers of liquid nitrogen. Neptune is the smallest of the ice giants, but it is massive than Uranus. It is made also of hydrogen, helium, and methane. Neptune will be the last of the planets to be discussed, since Pluto now is considered a dwarf planet. To sum up, teachers, let us sing the solar system song.
There are 8 planets in the solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun.
My name is Mercury. I'm the second hottest planet, the closest one to the sun. A year on my surface is 88 days. I'm the smallest, but I'm lots of fun. My name is Venus. I'm the hottest planet, but the second planet from the sun. I'm the brightest planet in our solar system, and I'm too hot for anyone. My name is Earth. And I'm the planet you live on, the third planet from the sun. I'm the only planet with organic life, so take care of me, 'cause we're all one. My name is Mars. I am red in color. I'm the fourth planet from the sun. I have the highest mountain in our solar system, a volcano named Olympus Mons.
There are 8 planets in the solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun.
My name is Jupiter. I am covered in clouds. I'm the 5th planet from the sun. My giant red spot is a raging storm. As for size, I'm the biggest one. My name is Saturn. I am brown in color. I'm the 6th planet from the sun. My outer rings are extremely thin. They're made of dust and icy chunks. My name's Uranus. I am blue in color. I'm the 7th planet from the sun. Humans have named me the icy planet because I am the coldest one. My name is Neptune. I am blue in color. I'm the 8th planet from the sun. I have too many storms in my atmosphere, and I'm the furthest planet from the sun.
There are 8 planets in the solar system. We revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun.
Did you enjoy the song? Now let's do this. Help me name the planets according to their relative size and its distance from the Sun by answering the questions or clues. Number 1. It is a star in the center of the solar system. The answer? Sun. Correct. Number 2 is the closest planet to the Sun. The answer? Mercury. Correct. Number 3, it is the hottest planet in the solar system. Your answer? Okay, it is Venus. Number 4 is the only living planet. Okay, Earth. Very good. Number 5 is known as the red planet. That's right, Mars. Next is the biggest in the solar system. You got it right, Jupiter. Next has a distinctive ring systems. What is your answer? Exactly, that is Saturn. Number 8 and 9 are the ice giants. What do you call them? Number 8 is Uranus and number 9 is Neptune. You got it right. Very good. Quiz time! I know, teachers, that this will be easy for you. Read the following questions carefully and write the letter of the correct answer. Question number 1. How many planets are there in the solar system? 2. All of the following planets are terrestrial except number 3. Which of this planet has the largest ring system? Question number 4. What is the hottest planet in the solar system? And last, it is the common term for the planet's natural satellite. Are you finished, teachers? I'll be waiting for your answers. Good luck! Okay, teachers, that will be the end of my presentation for today. Again, I am your teacher facilitator, Ma'am Sarah Jane A. Timbang of Lawakan National High School, saying thank you for listening, stay safe, and God bless.
Thank you, ma'am. Napakahusay naman po. And now, let's proceed to our fourth facilitator. He will be discussing strategies relevant to our third facilitator, the solar system. He finished his baccalaureate, bachelor in elementary education at Limay Polytechnic College, 2014. And in the year 2018, he also finished the academic requirements of the Master of Arts in Education, major in Educational Management at Tomas del Rosario College. In 2014 to 2019, he is an intermediate math and science teacher of Mountain View Village School, a private school in Maribeles District. He also a multi-grade teacher at Eva Aita Elementary School way back in 2019. And in 2019 to 2020, he also part of the Santo Domingo Elementary School as a grade 6 teacher and school science coordinator. And at present, he is now part of the teaching force of St. Francis Elementary School. Let us all welcome Sir Jardine Villanueva Barlongo. Hello, sir.
Hello, teachers. I hope you are doing good. I'm Jardine Barlongo, Teacher 1 from St. Francis Elementary School, Limay District. And welcome to our Division Webinar Series on Science Content and Teaching Strategies in the context of the most essential learning competencies for 4th quarter. We teachers are all new in this pandemic setting. It is difficult for us to teach in a way that we used to. Others are in virtual classes, and some are answering modules in remote areas. Today, I will share approaches on how we can teach the planets in the solar system using virtual science laboratory and remote science laboratory. What is a virtual science laboratory? In this approach, we can almost give hands-on experience of learning through the use of digital multimedia. It is designed to improve learning approaches by introducing a safe and interactive lab environment. This can be detailed diagrams, illustrations, or close-up pictures which give the full details of the lesson. It allows the learners to conduct experiments on their own and make repetition if needed. Earth science can be studied thoughtfully with virtual hands-on learning, allowing our learners to see the planets through images and videos. This approach can be exciting, useful, and enjoyable. Here are some virtual science laboratory applications. Number 1. Solar System Scope, a free downloadable app online. This science application gives a virtual model of solar system. It allows the users to see the virtual diorama of the universe. The users may explore via virtual tour and see the full details of each heavenly body. Now, let's try. Hello kids! I am Sir Jardine, your science teacher. Our lesson objective for today is to compare the planets in the solar system. Do you know where I am? Correct! I am in outer space. Today, we will have a virtual laboratory tour using the application Solar System Scope made with Unity. Come on, let's go! Welcome to our virtual laboratory tour. This is the solar system. Let's have a closer look in every part of this system.
Is only one of the billions of stars. The planets are categorized into two. The first 4 planets are in terrestrial group, and the last 4 planets are in Jovian group. Mercury. Mercury is the first and the closest planet from the Sun. It has no moon, no water, and no oxygen. It takes only 88 days to revolve around the Sun. Venus. Venus is the second planet. It has no moon, no water, and no oxygen. Venus is the hottest and the brightest planet due to high amount of carbon dioxide that traps heat. It is also known as the twin sister of the Earth because of their identical size. One moon, has water, and has oxygen. This is the only known planet that can support Mars is known as the red planet. This is because of its crusty surface. Mars has the largest volcano in the solar system, called Olympus Mons. It has 2 moons, the Phobos and Deimos. has around 62 moons, and 4 of them are Io, Callisto, Ganymede, and Europa. Saturn. Saturn is the second largest planet. It is popular because of its beautiful visible rings, which are made up of dust and ice. It has almost 150 moons, and the biggest is Titan. Uranus. Uranus is the coldest planet. Its temperature drops at negative 224 degrees Celsius. Neptune. Neptune is the last major planet. It is also known as the ice giant. This is the end of our virtual laboratory tour. I hope you enjoy and learn something. Here are the other online applications that you may use. Solar Walk Light, hence Solar System, Planet Exploration by New Path Learning, and Study Jams. Now, let's talk about Remote Science Laboratory. This pandemic, most of the learners are incapable in using technological advances. They don't have smartphones, computers, internet, and data connections. This approach doesn't need costly materials. The learners are given access to authentic scientific tools and opportunities to control remote lab experiments. They can use available materials to their homes. This would enhance their inquiry skills and conceptual understanding, and students can learn and explore with motivation. Upon doing remote laboratory experiments, learners can ask for help to elders if there are risky tasks to do.
Audio Jungle.
How can we conduct a remote science laboratory? Let us follow these steps. Number 1. Make a clear instruction that the parent and learner can understand and follow. Take note, you can use the mother tongue because, remember teachers, you are not there to explain the procedure. Number 2. Require the learners to use what's already at home. This can save money and may develop creativity and resourcefulness of the learners. Limit the materials to safe and non-electric materials. Number 3.
recording of remote labs or live laboratory procedures. Learners can record their laboratory procedures, then present in class afterwards. Or they can do live laboratory. But recorded remote lab is more advantageous because the learner can do modifications. Number 4. Providing online simulation. There are numerous available online simulations that you can provide. But be careful in choosing a simulation. Just keep in mind that a simulation must be a child-friendly, reliable, and interactive. And last, let the learners collect data and answer the questions. After the presentation, learners must answer the questions prepared by the teacher. How does this approach work if there are technical issues or lack of technological advances? Learners can still do remote laboratories by simply following the procedures and illustrate the laboratory procedures in a sheet of paper, or submit the output to the teacher. In that way, no students will be left behind. Hello kids! It's me again, Sir Jardine, your science teacher. Today, I will show you options and procedure on how to make a model of solar system using the available materials at home. You children are still prohibited to go out because of the threat of the virus. So be creative and resourceful in finding materials at home. We can do recycling if needed. This first example shows a model of solar system in a box. The materials in this model are used carton box, bottle caps, wire or string, scissors, glue, and coloring materials. The second example is a 2D model of solar system. It is made up of illustration board, papers, and coloring materials. The third example shows a 3D model of planets. This is more detailed model than the first two examples. It needs more time and preparation. This hands-on activity is called a papier-mâché modeling planets. The materials are used papers, balloon or any round object, glue, water, and coloring materials. Come on, let's watch this video. This is the end of my topic. Thank you everyone for listening. I am hoping and looking forward that you get something from my discussion. Let me leave this quote. There is only one corner of the universe you can be certain of improving, and that's your own self. By Aldous Huxley.
Yes, thank you, sir, for taking the time to share your knowledge with us. It is indeed a very comprehensive discussion. And before we end, let us hear from Ms. Cecil B. Delgado, chairperson of this webinar series. Hello po, ma'am.
Hello viewers! In behalf of our team, I would like to thank everyone who participated in this last leg of our webinar series. I hope that you enjoyed this and that you've learned something practical from our facilitators. We're now in our fourth quarter of this school year, and I believe that us teachers have not only survived but flourished in this time of the pandemic. This is because of learning opportunities that were given to us, such as this webinar series. And in line with that, I would like to thank every people who had made this webinar possible. Of course, including my team, who had been very supportive and generous in extending their talent, their time, and their effort in order to fulfill the needs of this webinar. And having said that, I hope that we all had a great day. Thank you.
Thank you so much, Ma'am Cecil. And also, thank you to all of the facilitators for sharing your ideas about your topic. Napakagagaling talaga kapag taga-Bataan.
Yes naman, sir. Totoo po yan. And thank you, Ma'am and Sir, for giving your time, effort, and expertise in your topic that surely our participants have gained a lot.
And that's for today. And we would like to thank the facilitators and participants for taking part in the success of this webinar.
And we also would like to share this quote with everyone. Nothing in life is to be feared, it is only to be understood. Now is the time to understood more so that we fear less. Again, on behalf of the persons behind who made this webinar possible, this is Ma'am Jam of Morong Elementary School, Morong District.
And I am Sir Alvin of Antonio Giliamas Elementary School, signing out.
Thank you.
Thank you, and God bless.